Today then? Alright. Mm-hmm.
What is the paper? Like, do you need a different paper to actually fill out?
Okay, so people that like Monroe who've taken a challenge program course before, already know about the program, so this is not like a big deal. Okay, she wants the blue page. I'm not going to pass out the blue page today. Pass it out after you decide you want it. So like next week sometime, like Monday, yeah, I want to do it. I'll pass out the blue. Okay. Because what happens is Tyson will lose his probably twice or 3 times. I just made that up. But I don't know. It'll get lost at some point. All right, so statistics. Okay, so big picture, overarching. What are we doing in statistics? What's the point of statistics? What are we going to do with it? Heidi, something. Good, comparing things. I kind of like that. Kind of like that a lot. In today's politically correct world, we sometimes say, oh, you shouldn't point out that about the person. Oh, you shouldn't point out why people are different. But isn't that what it always is in life? I mean, if it wasn't about things being different, A, well, obviously they'd all be the same. B, how can you distinguish between somebody? I mean, how could I describe Jenny if I didn't describe you that she's tall, that she raises goats, she's a little loud at times, whatever. If I didn't point these things out that were glaringly obvious about her, all right, how would I describe her? Well, she's a girl. But I couldn't even do that because that would be describing, I'd be differentiating between a guy, all right? So with statistics, I really like it because it's the real world, right? It's what we do. We always say, oh, I like that better than that. Oh, geez, really, that shirt on you? Seriously? This one would be better. Okay, we always compare, okay? And so this class is going to spend a lot of time comparing things. Are boys smarter than girls? Do girls take longer to decide what to eat for dinner? Does this cancer drug work better? Whatever it happens to be, we're going to be comparing things. I like that. What else? Come on, one thing. One answer. That's it. That's all I can muster. Come on, someone else. Go. Yeah.
Sort of like miniature science experiments. We're going to add one thing and see if it gets better or worse with that one thing.
So we're going to be doing some experimentation. I like it. Experimenting to see if one thing affects or causes a change in something else. Does in fact proactive solution get rid of your acting problem? Or is it just because you Jessica Simpson, you pay $10 million to go get him lasered off? I don't know. Okay? Who knows? That's life. But we're going to go figure it out. So yeah, we'll be doing little experiments. That's cool. One we did last year with the math department, worked pretty good. Just put the math workshop program in. Well, the whole idea was that it was supposed to improve math scores in the building. It was supposed to improve the scores in their tests and their scores in their algebra classes or whatever. It worked. Thank God it blew the doors off of what we thought it would do, so we didn't actually have to go test it, but if we wanted to, we could have gone and tested it. How do I know if it's changed it enough? How do I know if it's really changing or not? How do we figure that out? I mean, because what if my Miracle Grow changed the corn plant height about 2 inches? Would you notice that? I mean, it's a little imperceptible, isn't it? So we'd have to have some kind of way of going about testing it. And that's the cool thing, right? So we're going to do this experimentation, and then we're going to learn how to do testing, right? So we're going to test our results. Our results using probability. There's going to be times when it's not going to be really obvious. I mean, like last year, you could be a blind person and notice that our scores went from 30% to 70%. Okay, test on that. To go from 30% to 50%, that is a 66.67% increase. That's pretty crazy. That's ridiculous. You can't miss it. But if our numbers went from, say, we normally pass 38%, went up to 42%, could that have happened randomly? Yeah. We could have had just this really genius class come through. It could have happened. Okay? Freakish. I personally have had my butt chewed on numerous occasions by principals when Mr. Jarman, well not old, but old Mr. Jarman, when he was principal here, came in one day and said to me, right in a staff meeting, I swear to you this happened, I hadn't drank my whole cup of coffee yet, it's 7 a.m. in the morning, I'm half asleep, and he goes, boy, the math scores suck this year. I don't know what you guys did, but you're a bunch of idiots. And that's verbatim what he said. I'm like, okay. And like the whole year he just ragged on us. I'm like, seriously? And like he called me and why? I'm like, well, last year's class was a bunch of idiots. I mean, that's fact. I mean, look at them. Look at their scores in all their math classes. Talk to the math teachers. Walk down and talk to the 8th and 7th grade teachers. How did they do with their math? They didn't know math. They were terrible at math. And so the next year, did I change anything? So the next year he came in, I swear to you, same seat, because I used to sit in the same seat every day in the faculty meeting. Had my cup of coffee, 7 a.m. meeting, and he goes, I don't know what you guys did this year, but you guys are amazing on your test results. And everybody's like, hey, what'd you do different? Nothing. That happens, right? It happens. You can have this little whoop, or you can have a little boop up to that. It doesn't matter. What we had was a really below class, and then we had a really upper class. And so instead of a little fluctuation, this monster fluctuation, and you're like, oh my gosh, look at that. Crappy? Awesome. But it's not that big a deal. There's a little bit of perturbations either direction. But when you go from here to here, that's ridiculous, okay? That one I probably don't even need to test, but we'll see about it this year. But we're going to use probability theory. In other words, could we get the results? Could we get the results we got by random chance? And if the answer to that question is yes, there's a pretty good chance that we would see that just randomly, then probably what I did didn't cause it. But if the probability that we saw what we saw happen by random chances, like 2% chance of that happening, then I'm going to say, you know what, I don't think I witnessed a rare thing. I think I saw something that happens all the time. And I think it happens all the time now because we gave the plants Miracle Grow. Okay? Amy changed the color of her hair, and all of a sudden guys started like asking her questions about physics. Because why? Because apparently changing your hair color makes you look smarter. I don't know what it happens to be. Whatever it happens to be. And if that happens, if we can show that it's not, the probability of it happening by chance is very small, we're going to say, nah, I don't think it happened by random chance. I think it happens all the time. For instance, Drew goes down the street. He's going to go meet some girls. So he just he just keeps track of how tall the girls are walking down the street. And he realizes that, he took a sample of 2 random girls walking down the street. And the average height was 6'2". Yeah. So what are you thinking?
Girls on that street are tall.
Okay. He sampled 2 girls. He sampled 2 girls. And they average 6'2". Okay, so what does that say about them, both of them? Tyson? These 2 girls he talked to, here they are. And actually, I'm not going to draw them. I'm just going to draw their heads. Here they are. Here's the other one. I'm not going to tell you how tall they are. I don't know. All I know is their average height is 6'2".
Then one would either be like really tall, or they're both like around 6'2".
Okay, so one's really tall, the other one's a little shorter, or they're both around 6'2". I like that. That's cool. What else? But besides that, because I heard you say, boy, the girls on that street are really tall. Are they? Those 2 are. Now, where is he walking? We didn't tell you. I'm sorry. He's hanging out at the Rose Garden back when they used to play women's basketball, the WNBA. All right? And he was trying to get a signature of some of the hotties that came out of the floor there. and the one was 6'2" guard for Phoenix or whatever. Another one's 6'2" whatever. And so yeah, the two girls he saw were WNBA players. Whoops. Were they randomly selected? No, he's into WNBA chicks. No, they weren't randomly selected. It would be bad to say, geez, the height of women in the Rose Garden is all 6'2", because that's not true. If, however, he's like, I'm going to go over to Walmart or some randomly selected location, and I'm going to measure the women that come out of the store using a laser so they don't know you're actually measuring them. Just like some laser height range finder thing. I'm just saying. It would be more weird if he stood there and said, hey, how tall are you? That would be a little weirder, but whatever. So he does it from a distance so they don't know he's doing it, whatever. And if he like did, I don't know, 30 women come out of the store and the average height was 6'2", could he say something then? Yeah, probably. It's pretty hard to get 30 freaks in a row. Am I right? It is. Well, I'm sorry. How many girls do you know that are 6'2"? I don't know any either. If you saw one, they would be freakishly tall. Am I right? All right? That would be weird. If you got an average of 30 girls, they were averaged 6'2". That's crazy. But for every, see, last year I had a stats class, I had Chelsea Colson in there, who's 6'2", freakishly tall, or whatever she is, freakishly tall. You had Zach Sweeney, freakishly tall. Jamin, freakishly tall. Who else did I have in there? Rides motorcycles, Garrett McIntyre, who's pretty tall. There was another kid. There's like 5 guys in there that were 6'4", 6'5", 6'7", whatever, right? Plus Chelsea. On the low end of the scale, they had Mickey Simpson, who's 5'0". You had someone else who was like 4'9", or 4'11", I mean, he's like right there, okay? And, Chelsea's best friend, short. Yes, Kristen, who's short too. And so you had this, and Sean Mellon, who is also not particularly tall. But when you look at the average, for every tall boy, for every tall kid in the class, we had pretty much a short counterpart. What does it do for our average? It tends to wash the freaks out, doesn't it, right? And you end up with an average that's, well, why is it an average? It's in the middle, right? Now, true story, Mr. Jarman, again, was not the most astute math person. He's a PE guy after all. No kidding, he took me aside one day, he's like, look, Jake, we really want to improve math scores. He's like, all schools in the state should score above the state average. And I took a drink of coffee and I went, we're all above the state. Yes, we can all be above the state average. I'm like, hey, the average is in the middle, dude. You can't all be above the state average. And I could not explain it to him. I said, the best we could all do is if we were all at the state average, right? If we were all 6'2" whatever, right there, boom. That's the best we could hope for. We can't all be above it because it would be higher. You can't do that. And so, we're going to be looking a lot with averages, right? But what happens with an average? Hey, you wash out the uniqueness, right? The uniqueness of it, because you wash out the really tall people, the really short people, the really smart people, the really not so bright people. You wash them out and you end up with, well, there it is, right there. Okay? Those are the sorts of things that we're going to spend a lot of time with, right? But we'll deal with averages. And why is that? Well, you can't deal with individuals in general, right? Did Miracle-Gro work overall? That's what we want to know. We don't want to know, did it work for just the extremely tall plants already to help them? Well, that's not particularly helpful. Did it work for just the low-level plants, but then it actually did it like a political thing? It helped the poor little struggling plant, but it retarded the growth of the taller plant? That would be bad. That would be bad. Or did it work for everybody? Did it lift everybody up, right? That's the whole goal of the thing, right? We want to know, did it help the average? So we're going to spend a lot of time with that. So we'll be spending quite a bit of time seeing what's happening with all these different things. We'll take samples. Randomness really matters, right? You can't just go and pick your own poison, pick your people. That's not cool. If I could pick a whole class of people, I pick a whole class of these 3 right here, right? You can't do that, all right? And why would I pick them? Because they're nice, they're fun, they talk, they're pretty smart, they're hardworking. But in general, you get random people thrown in your class, right? Like yesterday, my freshman class. I'm getting too old for freshmen. I really am. I was just yelling, I'm like, you need to grow up. I don't need this 8th grade mentality in my high school class. Like the one kid, like calling out the roll, and she's like, and the most kids present or here, pregnant, ha! You get it? I said pregnant, not present. I said pregnant, ha! I'm like, I was like, wow, that's great. That's great. That's neat. So we get what we get, right? I mean, you're stuck. Here's these 25 kids, Mr. Goom, go and have fun. Are they represented in the whole freshman class? Unfortunately, probably yes. Yes, they are. If I could pick them, would I have picked those 25? Probably not. Probably not. But that's what you get, right? And that's the whole goal when we go out to do these things. You're not going to go, hey, look, here I planted this corn. Here's this row of corn here. I'm going to pick the 12 best plants all this row. That's not cool. You can't do that. That doesn't tell me anything. So that's not going to work. We need to really work on randomness. Now, how do we work on random? We're going to study that a lot. Also the idea of not only the averages, but how spread out things are, right? So if you have this itty bitty little corn plant and this giant corn plant up here, the average might be this middle corn plant. And if this was your field, you probably wouldn't have a very good crop. However, if your field looked like this, oh, neat, look at you. Which field has better plants, probably? Probably this one down here. Probably this one on the bottom. Probably going to average better yield all the way across. You got good plants all the way through. Do they have probably the same average height? Mm-hmm. Is there less extremes? That's cool. I was talking to Dana Dominigini's dad. He works at Widmer Brothers Brewing. If the average beer that came out had an average taste or an average quality, over the, if every batch of beer came out with and if they averaged all the alcohol or all the sampling taste or whatever, and it all averaged out the same, would that be enough as a beer person? Because nothing worse, I would think, than cracking open what you think is going to be a very nice, tasty, cold one at the end of the day, and pour it down your mouth, and it tastes like, I don't know, just rotten rat syrup of some sort or another. And you're like, what is this? And her dad goes, well, geez, the average was great. That's nice. I want it to taste good. All right? Or like a bottle of milk coming off the shelf, right? Here's the packing plant. Here's these bottles of milk. Those are bottles. Supposed to hold a gallon of milk. Right? So what happens if they kind of look like this? Yeah. But the average, Mr. Groom, the average was 1 gallon. That's nice. That's nice. I'm getting hosed. That's not okay. So average won't be enough always, right? We're going to have to worry about how spread out things are. And in a quality control environment, the average, I could care less so much about the average more than I really care about is what is this spread? And we call it the standard deviation. But what's the variance here? How much does it vary from what it needs to be? And you want that to be small. Because when you're selling something, you want people to have, why are Burger Kings and McDonald's and Taco Bell's, why is it that all across the United States, no matter where you go to Athens, Georgia. I don't know why you're there, but you're there. And you're like, I want to go to Taco Bell. So she goes to Taco Bell and she orders a grilled stuffed burrito, and she comes out feeling good about it because, dadgummit, it tastes just like the one she got in St. Helens. That's kind of a big deal. Because when you order a Big Mac or you order a Whopper, you'd like it to taste the same wherever you go. Because if it tastes one way here and another way over here and another way over here, what have you just done? You've ruined your whole image, right? You've ruined the whole product. You've ruined it. And you've ruined it not because the average is such, but you ruined it by the variance of it. And that's what we're going to study a lot about that as well. Okay? We can't have that. And so those are the kind of things we're going to be doing this year. Kind of going from that standpoint. Any questions about that? Now, second half of the year is going to be more fun, I'll give you that. First half of the year, first 2 chapters, a little dry. Not going to lie to you. And the next couple of chapters are okay, but it's probability. So, it's kind of fun. It's not hard. It's not the best. But when we get to chapter about 6 and 7, that's when it gets really fun. We start testing, does Miracle-Gro work? Do people talk to you more when you get a nose ring? Just whatever it happens to be. I don't know. I'm just saying. Probably not. Who knows? Okay? But that's where we're going this chapter, this year. So, let me see your book there, kiddo. All right. Tonight, I was like you. you to go home and read through chapter 1. Chapter 1. And in chapter 1, I will go over with you next time some of the big... Will I go over with you, or will I have a pop quiz? I may have a pop quiz that I'm telling you about right now. Over some of the terms in chapter 1. Now listen to me, there's no homework per se. There's a little, I'm going to pass out the homework here in a minute, but there's no math on it. Chapter 1 has no math. It's all definitions. Can you read and follow along? Okay? So chapter 1 is very straightforward. You're going to read through that. We'll go over some of that next time. And then next time we're going to jump into chapter 2. Okay? I'll pass out the homework sheet right now. But I think, yeah, I'm glad we're pop quiz.